Okay, so, and to warm up for this, well, we're just gonna play a little game to warm up here. I'd like somebody to tell me here, tell me one of the numbers behind, I don't care which one, tell me one of those numbers.
88.
No.
1.
No.
1 is
Zero.
64. 1 is 64.
2? Okay, raise your hands. We'll see, yes, sir.
64.
No.
32.
No.
With 2 times 32.
16.
No.
4.
No.
X.
No.
Pi.
No.
Square root.
No. You guys are terrible at this game.
I was
Terrible. I would have accepted either -16 or -4. That was terrible.
That's
Everybody got it. My goodness.
It's not trick.
Oh my goodness. Okay, so let's see if you have better luck this time. So I want all phones and earbuds and stuff should never be out in here when I'm doing this stuff, right? Okay. So let's try again. How about the next one? Actually, can you tell me one of the numbers behind these boxes?
0. It's definitely gonna be 0.
Do you
-1.
agree with that?
Yes.
Okay.
I'm just right in and say no.
How are you so sure? You're right. How do you know?
Because, I mean, well, first off, you can't pull the whole plus or minus thing off the 0, but also because anything multiplied by 0 is 0, you can't get 0 by multiplying anything else.
That's it. That's the zero product property. Okay, that's it.
Oh,
The
that's it.
only way, think about this, the only way you could multiply numbers together and get 0 is by multiplying by 0. There's no other way, right? You have to multiply by 0. So guaranteed, at least one of those numbers is 0, and at least one of those numbers is 0. Guaranteed, right? So that is what we call in math, we give it a fancy name. The zero product property. The only way that you can get 0 in a product is by multiplying by 0. Okay, well that's a good warm up. Gets us going, thinking about some things. Okay, so let's solve a couple of equations. What about that top one? How am I going to solve that top one? What's my strategy? Okay, well what are you trying to do here? You're right. It's the correct first step. Trying to isolate x. Good. So we add 7. So that gives us 4x squared equals 16 divided by 4. Good, you guys are getting good at this. So x squared equals 4, so x equals
2.
4
Plus or minus 2.
plus or minus 2. Okay, so we got two solutions there. Both of those work. Those are the values of x that would make that equation true. Okay, we're on a roll here. What about that bottom one? Subtract 20. Okay, then what? Ooh, what's the problem? Oh yeah, this isn't gonna work.
You can't add like terms.
Yeah, we can't add like terms, and so we're stuck with two different x's no matter what we do. There's two terms that each have x, and so I cannot isolate x.
Yes.
So the strategy that worked up here does not work here, does it? We gotta come up with something else. Okay?
Yes.
So to come up with something else, I wanna practice something. Let's think about something here. What if we took, for example, let's take this product and see what we get. Let's just see what happens. If I multiply this out, what am I gonna get? Well, how would you multiply this out? You have so many ideas. I heard FOIL, right? We're gonna which means distributing. So I'm gonna distribute the x, and then I'm gonna distribute the 3, right? So what's that gonna give me? What's x times x?
X squared.
Okay, what's x times -7?
-7x.
What's 3 times x?
3x.
What's 3 times -7?
-21.
Oh, it's not equal. Minus 21. So I could write then the quantity x plus 3 times the quantity x minus 7 equals, if I combine like terms, what am I going to get?
X squared equals 4x minus 21.
Okay, good. So doing that process, you guys are great at that. You've done that a million times. Going from here over to here, we call expanding in math, or multiplying, really, right? We use a fancy word, we say expanding, but it's really just multiplying, okay? Here's the challenge. Could we go backwards?
C.
Could we? Could we start here and end up there?
Yeah.
Okay. How could we have done that? Could we have started with x squared minus 4x minus 21 and determined that that expression is equal to the product of x plus 3 times x minus 7? Okay, you see how that could be useful though, right? What if? That could be very useful. If we had, for example, I have a word up here, yeah, I'll do it. So, what if we had the equation x squared minus 4x minus 21 equals 0? Well, I don't know how to solve that because I can't isolate x. But if I were to rewrite x squared minus 4x minus 21, if I were to write that as a product of two factors, right? X plus 3 times x minus 7. That might be pretty helpful. Can anybody tell me what the solutions are now? Yes, sir.
-3 and 7.
How'd you get that? Okay, but there's something more than it just being the opposite. Those are important values. Why does x equals -3 act as a solution?
Because -3 plus 3 equals 0 is
Ah,
0 times
okay.
-4 is 0.
Okay, so really think what we're doing here. We're playing the same game that we played on this page here, aren't we? Right? We're saying that the only way we can get a product of two factors to equal 0 is when I multiply by 0, right? So in order for this factor over here, x plus 3, to equal 0, well, and we could even just write that down. If I want to solve the equation x plus 3 equals 0, that's pretty easy to solve. I just subtract 3 from both sides, and I get the answer, x equals -3. That's the value of x that makes that factor have a value of 0. And 0 times, who cares, is 0, right? Anybody see that? Okay, what's the other value of x that would work then?
Yeah, so
7, right? Because that's the value of x that would make this factor equal to 0. Okay, so being able to write this in factored form, that was huge, right? That made this a really simple problem. Right? So how can we do that? What was the trick? How could we have gone from here? And what's this process called, by the way, if we start with something like this that's a sum of a bunch of terms and we write it as a product of smaller factors? What do we call that? Factoring. Right? That's factoring. That's when we talk about factoring in math, that's what we're doing, if we're involving variables at least, right? So what's the trick? How could we have gone from x squared minus 4x minus 21 to x plus 3 times x minus 7? How could we have filled in those blanks? Well, how do we know that these had to be x's? Okay, because there's an x squared. And how did we get the x squared? We distributed the x to the x, and that gave us x squared, right? So the fact, I'll try to kind of color code this a little bit for you. So the fact that we had an x squared here, that told us that the first term in each of those factors had to be an x. Now we got to get the numbers though, right? What about the numbers? Well, what's special about 3 and -7? Where did this -21 come in when we multiplied this out? Okay, that was when we distributed the number to the number, right? So when we multiplied the two numbers, we got a value of -21. Okay, so we know that the numbers have to multiply. They have to multiply to whatever the number at the end is, the constant, right?
there's only two sets of numbers.
And how many ways could you do that? Well, in this case, there's more than that. You could do -7 and +3. You could do -3 and +7. What else could you do?
-1 and 21.
-1 and 21, or -21 and 1. There's a bunch of different possibilities, and some numbers will give you lots of possibilities, right? And sometimes maybe you find that none of them work too. Okay, but we gotta be able to distinguish between those. So knowing that they multiply to negative 21 wasn't quite enough. What about this negative 4? That might be important too, right? We've got this negative 4 right here. How did we get that? Where'd that come from? That negative 4x.
3x minus 7x.
So 3x plus negative 7x, right? Well, where did those come from? Those are the numbers we started with, right?
Yeah.
Because all I did was distribute the 3 to the x and gave me a positive 3x. I distributed the negative 7 to an x and got a negative 7x. And so the sum of those two numbers of x gave me the negative 4x, right? So what's the trick there? Well, all we had to do was just add the two numbers to get negative 4, right? So think about that then. We've got two clues here that are always going to allow us to figure out what those numbers are if they exist, right? So if we started up here, we could have said, okay, I need two numbers that are going to multiply to negative 21 and add to negative 4, and there's only one combination of numbers that do that, positive 3 and negative 7. See how that works? So all we're doing is we're just kind of reverse engineering the thinking that we did when we multiplied this out. Okay, so let's go back up to that problem I originally gave you at the beginning of the period then. What about this one right here? See if we can do this. So our goal is we want to see if we can break up x squared plus 9x plus 20. We want to see if we can break that up into a product of two factors that equals 0. If we can, we got the solutions nailed, right? Okay, well, what has to go here and here? X, okay, because I've got an x squared. What do the numbers have to multiply to?
5 and 4.
Okay, but what do they, okay, you got the answer, but what do they have to multiply to?
20.
They have to multiply to 20. Okay, so we're gonna multiply there, and they have to add to 9. They always are gonna multiply to the constant and add to the coefficient of x, right? So there's a couple things you can do to make this easier. For one thing, I talk about the sign game. Think about the signs. If the two numbers multiply to a positive, what does that tell you about their signs? They're either both positive or both negative, but if they multiply to a positive and add to a positive, which one is it? They're both positive. So let's put the signs right there. We know they're both positive. And then we just have to see if we can find magic numbers that multiply to 20 and add to 9, 5 and 4, right? Okay, so if that's the case, if the factors are x plus 5 and x plus 4, x plus 5 times x plus 4 equals what we started with, what are my solutions then?
Negative 5, negative 4.
Negative 5 and negative 4, because we're just going to set that factor equal to 0 and solve. Do you have to write that out? No, you probably do it in your head, right? So either x equals negative 5, or what's the value of x that makes that 0? Boom. How would we check this on a test?
Plug it back
Plug them
in.
in, right? No big deal. Okay, try another one. Try this in your notes, on your own. If you don't have your notes out, grab those real quick and try this. Okay, take a second, see if you can get an answer here. Okay, Paul, what goes there and there?
X.
X, good. Not an X squared, those have to be X's. Okay, what do, Chelsea, what do the numbers have to multiply to? -45. Okay, multiply to -45, Aaron, what do they have to add to?
Four.
4? -4. Okay, they gotta multiply to -45, and they've gotta add to -4. Okay, let's play the sign game. Big Connor, if they multiply to a negative, what does that mean about the signs of the two numbers? If two numbers multiply to a negative, what does that tell you about their signs?
It means one's positive, one's negative.
One's positive, one's negative. Good. Okay, so we know that they're opposite signs. What if they add to a negative? Which one must be bigger? The negative, right? Okay, so let's do this then. Let's always write, whichever one's bigger we'll put first, okay? And we'll go find those numbers. So what would they be? What numbers would multiply to -45 and add to -4? Is that what you're gonna say? All right. -9, +5. And so what's that give us then for our solutions? What do you think? Stephanie, what'd you get for your solutions?
5 and, -5 and 9.
There you go, good. So x equals 9, that's gonna make this factor 0, or x equals -5. What if we plug in 9? We'd get 0 times 14. Well, 0 times anything is 0, it works. What if I plug in -5? I'd get -14 times 0, 0, right? Okay, how about this one? Let's do a couple more examples and I'll let you guys work. This one looks harder, but it's way easier. Here's my hint. The factoring process here is much simpler. You don't have to find any magic numbers or anything. Factoring here is pretty easy. Okay, let's get those Chromebooks closed. Let's do some sneaking open here. Close those up. You have questions about this, for sure, if you don't. Okay, so, of course not. So Gabe, any ideas what we could do with that? I don't need any magic numbers. What could I factor here? Matt, you got an idea? Okay, so you could make it, that's an idea. Now, we can do this easier, but that's a pretty clever idea. Tell me if I'm doing this right. What you're suggesting is we could write this as x squared minus 3x plus 0? Is that what you're saying? Okay. So we could do magic numbers then. What would they have to multiply to? 0 and add to? So what would those, if they have to multiply to 0 and add to -3, what are they? -3 and 0. Yeah, so we could say x minus 0 times, or plus or minus, doesn't matter, right? And x minus 3, well, that's the same thing as saying, what's x minus 0?
Whatever X is.
But that's just plain old x, isn't it?
Yeah, so
Right?
one.
We don't really, if I say, how far did you run today? Well, I ran at 5 minus 0 miles. He would say I ran 5 miles, right? You don't put a minus 0 in there. Minus 0 is not necessary, right? So we'd have x times x minus 3, right? Okay, could we have gotten that more easily? Could we have done that in one step over here?
Just put in X minus 3.
But how could, okay, we could just factor out an x, right? We could factor out a greatest common factor. What is a greatest common factor? The biggest thing you can undistribute from everything. What's the biggest thing I could undistribute from both of those terms? X, right? So I could undistribute an x, leaving behind what? X times what is x squared?
X.
X times what is -3x? Right? Okay, you don't even really have to do that. You can just undistribute an x to get that in factored form, right? Now that it's in factored form, and what do we mean by that? That's a fancy word, but all factored form means is just written as a product of factors. Right? That's what we're trying to do, is put these into factored form, and once they're in factored form, it's easy. What's the value of x that makes this factor 0? 3. Right? So we can have x equals 3, or What about that one? It's so easy, it's hard. 0, right? The value of x that makes x equal 0 is 0. No, right? Oops, that's terrible. Oh my gosh, happened again. X equals 0 or x equals 3, right? So if we ever can, we always want to try to factor out a greatest common factor. That makes our lives easy, right? That makes the whole process much easier. One more. How about this guy? Now, different question. We're just practicing the skill of factoring. This one says completely factor, which means we want to break it apart into a product of as many different factors as possible. This is like saying, if I told you to completely factor, let's say, 30, the number 30, that's where we'd use a factoring tree, right? What did we do with 30 to break it up using a factoring tree? 3 and 10, let's say. How about 10? So 30 is equal to 3 times 2 times 5. It's completely factored. It's broken into a product of its prime factors, right? We're going to do the same thing here. We want to break it into as many small factors as possible. So what can I do first? Factor out a 2, right? Without taking out the 2, this looks hard. I've got a 2 in front of the x squared, which is different. It makes it a little hard. But we could undistribute a 2, right? If I undistribute a 2, what's left behind?
X squared.
X squared. 2 times what is 2x squared? X squared. 2 times what is negative 2x? Negative x. 2 times what is negative 40? There you go. So this is what we call, once again, this is a greatest common factor, right? Is 2. Are we done? Maybe, but we're going to try to see if we can break this apart, right? So this whole thing is equal to 2 times. The question is now, can we break this quadratic trinomial? That's a fancy name. It's got 3. We won't even worry about that. We'll talk about that later. Tri means 3. It's got 3 terms, but it's just this quadratic expression. Can we break that apart into a product of factors? What would have to go here and here? X, good. Okay, what would the numbers have to multiply to?
20.
Negative 20. Got to multiply to negative 20 and add to, what is it? Negative 1. Right, what's the number in front of x? Negative 1, right? So they got to add to negative 1, whatever the number in front of x is. So what would those numbers be? If they multiply to a negative and add to a negative, opposite signs, which one's bigger, negative or positive? Negative. What are they?
So it's going to be positive 4 and negative 5.
There you go. Negative 5 and positive 4. So that's factored all the way. That's completely factored. I can't break it apart anymore. How would I check to see if I did it right? Well, can't really plug it in this time. But I could multiply it all back out and see if I get that, right? If I did, I must have done it correctly. Okay. What if the question was asking instead, let's just say hypothetically, that it was asking us to solve that equation, right? Now I've got it factored. What would the solutions be? Okay, x equals positive 5. That's when this factor is equal to 0. This factor is equal to 0 when x is negative 4. When's that factor 0? That one's never 0. But that one's always 2. It's a constant. Does it need to be 0? No. Only these factors, we can pick x's that would make these factors 0. But still, the product of 2 times 0 times something else is still 0. All you got to do is multiply by 0 once to make the whole product 0, right? Okay, make sense? Okay, so there are going to be 2 assignments up. You're kind of just practicing this kind of stuff. Okay? All right, have at it. Yes.